All right, let's get started. This is Algebra 1, Lesson 83. That is page 543. We will go through this. This is talking about factoring. We've done several ways of factoring, and these are called the special products of factoring, and there's two different ways, but mainly I think for this lesson you just need to memorize one main thing, and that one main thing is difference of two squares. We use it all the time. Let's look over here. Perfect square trinomial, just so we can understand where this comes from. You have a binomial, a plus b squared. Remember, that doesn't mean a squared plus b squared. What it means is a plus b times another a plus b. And when you multiply them too, you get the first term squared. Remember, a and b means first term, second term. So first term squared plus 2 times your first term and second term plus your second term squared. And there is the sum and there's the difference because it's subtracting, and same concept, just the minus sign there. So here, let me show you a trick for these. You don't have to memorize them, but you do have to put them in this format. So here is x squared plus 6x plus 9. Let's go ahead and do it the normal way, meaning factors of c that equal b. So c is plus 9 and b is plus 6. So factors of 9 that equals 6. When you're dealing with perfect squares, you need the same number. When you multiply, you get c. When you add it, you get b. So here, I know that 3 times 3 gives me 9. I know 3 plus 3 gives me positive 6. So I have x plus 3 squared. There are two factors. It's x plus 3 times x plus 3, but you're not going to put two binomials. I only need one. If you give me x plus 3 times x plus 3, it's going to be wrong in your homework. So here, x plus 3 squared, and that's your answer there. Another way you can try to figure it out is if you square root the first term and the last term. Let's just do over here on the side. You get x, and you get 3 here. Here, according to this, if you multiply 2 times your terms before you square this, so 2 times x times 3, so the two numbers that you squared, you should end up with your middle term. So 2 times x times 3 gives you 6x, and you end up with your middle term, and that's why it's a perfect square trinomial. But you can just factor it the normal way, and you'll get your answer here. X squared plus or minus 2x plus 4, factors of c that gives you b. So b is negative 2. So factors of 4 that gives me negative 2. The only factors of 4 I could think of is 1 and 4. It's positive, meaning both of them are positive, both of them are negative. So here, 2 and 2 plus 2, positive 2 and positive 2, multiply, you get 4, but 2 plus 2 gives you 4. Negative 2 plus negative 2, remember, it's positive, so both signs have to match up. In this case, there's nothing that works out. This is not a square trinomial. So it does not define it, because when we try to find factors of positive 4 that equal negative 2, nothing shows up. Now let's do example 2. So here, we have to go ahead and simplify. Remember, the basic rule for factoring, you always start to see if there's any factors, any numbers you can factor out, or any variables you can factor out. Here, for each of these 3 terms, they have one term in common, and that's the pi. You can factor out the pi. When you do factor out the pi, you end up with r squared plus 10r plus 25. Now you can factor. So let's say here we have a trinomial. Let's go ahead and try, not this way, just the normal way of just figuring out, finding factors of c that equal b. So positive 10. So factors of 25 that equal 10, that would be 5 and 5. Same exact signs. So therefore, your answer is going to be pi times r plus 5 squared, because it's the same factor. It's not r plus 5 times r plus 5. It's going to be r plus 5 squared. And you have to include that because we factor it out. You always leave it on the side. The most important one about this whole lesson is difference of two squares, meaning the first term squared minus the second term squared is equal to your first term plus your second term times your first term minus your second term. The most important part is you have to get it in terms of squared. You have to have it in this format. Also, it's a difference you have to be subtracting. If it's adding, you can't apply this rule. It's not possible. There is another formula, but it's really huge and it's very complicated. So for difference of two squares, look at the name, difference. So that means they have to be subtracting. Example 3a, 4x squared minus 25. It's not in the format of the first term squared minus the second term. We have to put it in that format. So what we do, and this way works every time, you square root the first term and you square root the second term. Let's look at the first term. There are two factors underneath the radical. It's 4 and x squared. So the square root of 4 is equal to 2. And the square root of x squared, think of, and I have the rule right here, whenever you have a root and you have a variable with an exponent, it's always your exponent divided by your root. Here, there's no number on this root, so it's a squared root. So we have the exponent 2 divided by 2, and that will be just plain x. 2 divided by 2 is 1, so you're going to end up with x. Here, the square root of 2, remember squared and square root, they cancel out. So that's why you're left with just an x. And then minus, we bring it down. The square root of 25, it's a perfect square, and they should always be perfect squares. And that is 5. Now your first term is 2x, your second term is 5. Not 2x squared, not 5 squared, just what's between the parentheses. So now we have our first term, we have our second term, and all we do, we just follow it with the formula. The first term plus the second term times the first term minus the second term. They're exactly the same, just opposite signs in between, and that's how you would factor them. B, we have this factor up here, 9m to the 4th minus 16n to the 6th. Always want to make sure if you can factor out any numbers. In this case, you can't really factor out any numbers. Variables, they have an m and n. You can't factor any common factor out, so let's go ahead and start finding the difference of two squares. It's subtracting, so we can. So now let's go ahead and find it. Here we have two terms. We have 9 and m squared. So the square root of 9 is 3. And then m, remember, it's your exponent divided by 2. So your exponent is 4 divided by 2. You're going to get m squared. To double check your work, m squared times squared gives you m to the 4th power. Now let's move on to the next one. The square root of 16 is 4. And for your exponent, you divide. So 6, exponent divided by the root. 6 divided by 2 gives you 3. And therefore you have your first term, you have your second term. Your first term is 3m squared, what's between the parentheses. Your second term is 4n cubed. And now we just go ahead and plug it in. First term plus your second term times your first term again minus your second term. And that's it. Next one, x squared minus 8. You square root both of them. So the square root of x squared is x. The square root of 8. 8 is not a perfect square. So here, this does not work out and you're not able to use the difference of two squares. They have to be perfect squares. And now let's do D. Here is negative 64 plus z to the 8th power. Remember, we can't have anything adding here, but let's go ahead and just move them. So we're not changing them from an equal sign. That's why their signs don't change. I'm just going to put this one first, which was positive, and then put the 64 second because it was negative. And now when we look at it, it looks like a difference of two squares. The rule, square root the first one, square root the second one, square root of z to the 8th. So it's the exponent divided by the root. 8 divided by 2, you get z to the 4th power. And square root of 64, you get 8. Your first term, z to the 4th power, your second term is 8. So then, when you get your binomials, it's your first term plus your second term and your first term minus your second term, and then that's your answer. Last one, example 4, they talk about a word problem with two different areas. Before we even begin reading it, we have to understand that area is length times width, and we're trying to find the area without one of the pawns in there. So the first thing we need to do is we need to find the area of each one. So the area of the large square, we have here that it's 2f by 2f. So that means when we multiply it together, you end up with 4f squared. The area of the pond. They told us that the area is equal to 225 for the length times width. It's a square, so if it's a square, that means if one side is 10, the other side is also 10. So another way I can look at this is L squared. Because the length times width, but the length is equal to the width. So I can have length times length is equal to 225. It's a perfect square. So the formula for a square is actually side squared. So if you don't like the L squared, you can do side squared. And to solve for one of the sides, you find the square root of the area. It looks like each side is 15. But now, reading the problem, it says, use a difference of two squares to write an expression that represents the area of the border. So now, we're going to represent the area of the border. So the large square, we're going to compare it. It says find the difference. So we're going to compare it to the area of the smaller, which is 225, or in terms of 15 squared. We have to make sure both of them are in terms of squared. So the second one, we already did the work for that one, but we didn't do the work for this one. We can easily go ahead and find the difference of two squares there. The square root of 4 is 2. The square root of f squared is just f. And now we have it in terms of there, but now they want us to put it as two binomials. The first term, 2f, not 2f squared, just 2f, plus your second term times your first term again, minus your second term. And there you go, that's your answer there. So if you guys have any more questions, make sure you go down there and let me know. Thank you.